All right, welcome back to dimensional analysis. This probably looks pretty familiar. We're converting between units, and last time we did a pretty simple problem where we were just doing hours into minutes and miles into kilometers, and things that you could still probably do fairly simply. So we're going to move on to some little bit more challenging ones. So we have one that says how many centimeters are in 25 feet. And again, yeah, you may know how many are in 25, but remember we're practicing with simple stuff because eventually we're going to have to do, this is chemistry, 2.504, etc. So,
What, Mr. Patterson, why do we have two conversion factors there?
well, some people do know how many feet are in a centimeter or how many centimeter in a feet, and if you happen to know that, then you can do this in a one-step problem. But it seems like in this case it'd be easier to go from centimeters to inches and then inches to feet. But you could do it really all sorts of different ways.
All right, I'm ready.
All right, so what you do first is you write down the number 25 feet. I didn't really even read the problem for the most part. Just write down the number in the unit, draw my line, I put that unit at the bottom. Okay? And now looking at my screen, I have only one thing listed that says that it's equal to feet. So I have inches. Put inches there. And I know that 12 inches are in 1 foot. And then I cancel my units. So if I finish the problem right now, I would know how many inches I have. But the problem's asking for me to go to centimeters. So I've got to draw the line and continue a little bit more. I'm going to put inches at the bottom. And I have something that says it's equal to a centimeter, so I can go ahead and put that up there now. It says that 1 inch is equal to 2.54 centimeters. And now I can cross out my units. It doesn't matter that one says inches and the other says inch. And I would do 25 times 12 times 2.54 on my handy dandy calculator. Mr. Z, did you calculate it in your head?
I almost calculated in my head. I'm going to do it one more time.
Okay, should have
762.
762.
You're just 150 centimeters off.
Yeah,
Between friends,
close.
that's not too bad.
No.
Now, what could you do it another? Could you multiply this a different way? You said, can't you just do 25 times 12 times 2.54?
Yeah, it really, as long as I'm multiplying the top numbers and dividing the bottom numbers, then I'll get the same answer either way. So I could have done 12 times 2.54 times 25. Now, I'm looking at my starting number and I see that I have 25 and it only has 2 digits and my answer has 3. So should we
That's
teach
right.
them about significant
That's
figures
right,
now,
significant
or is
figures.
that going to come up later?
No, we should know about significant figures by this time. So
Okay, all right. So since my starting number only has 2 digits, my ending number can only have 2. So I'm going to change it to 760. It would be kind of weird to just completely change it to 76. So 760 centimeters is a more accurate representation because I didn't have 25.4 feet or 25.13 feet. I just had 25, which is a pretty rough number. And changing it to the metric system, I shouldn't misrepresent it by having many more digits. So that's why we show it as 760 centimeters.
seems pretty simple. It's like combining two smaller problems into a bigger problem. That's what it
Right.
kind of looks like.
Yeah, and I know that these will eventually get tougher, but you want to do one with double units?
Yeah. So this was like a two-step conversion. The next one we have is actually you can call it two-dimensional or a double units, sometimes called, and that's this one here.
Ooh.
So
I'm glad you're doing this one. This one looks a lot tougher.
let me take a stab at it and correct me where I go wrong. So we're asked to convert from 32 miles per gallon. This would be, for example, the fuel efficiency of a car.
It's not my car, that's for sure.
That's pretty close to a European car, right,
Or maybe a newer car.
newer car.
Yeah, mine gets 10, 12.
The 32 is pretty good nowadays, I think. So we're going from miles per gallon to kilometers per liter. Now notice I'm going to just down here, I'm going to show you, we're trying to go from miles per gallon, and the way I'll do it is I will write whatever's on top of the fraction, whatever's on the bottom, And then we're going to end up with kilometers per liter. And I'll go ahead and you can write liter if you'd like.
So is that what they would use in Belarus?
Exactly right.
Okay.
Driving down, that's what they would use in my old country.
Okay.
So
So we're working backwards here.
exactly right. So what we want to do is we want to convert miles to kilometers. That will take a conversion factor. And then we want to convert gallons to liters. That will also take a conversion factor. And notice we're given both of these conversion factors.
Oh, that
Yep.
makes it easier.
The setup will be the same. The only thing to watch for is that the bottom will cancel with the top and the top with the bottom. And let me show you what this would look like. So you always still write the number that you're beginning with, which is 32, and I'll go ahead and write it as miles, and then let me divide the whole thing by gallon. And really it's miles per 1 gallon. So oftentimes, whatever per, just put a 1 there. So 32 miles per gallon. Then let's go ahead and multiply by our conversion factor. I'm going to go back to my method. So notice I have to convert from miles to kilometers. So let me do that first. So since I have miles on top, where would I put the miles in my conversion factor?
I guess in the bottom.
Go on the bottom. That way it could cancel out. Now I have to, what I put on top is what that conversion factor says. And the conversion factor says 1 mile equals 1.6 kilometers. So I have to put kilometers on the top. Notice I'm always using the conversion factor. This is a conversion factor. So I'll just fill in the numbers. 1 mile, 1.6 kilometers.
Okay. Now that's kind of nice that we had that conversion factor. I had some where I had to go from miles to feet to inches and centimeters and then kilometers. I guess this was a pretty handy little conversion thing. Hopefully they get that lucky on the test. Do you think it's going to happen, or?
Yeah, I don't have, students usually don't have to memorize general conversion factors. They will have to memorize metric, so how many grams in a kilogram. But most of these are given. Yeah, you're right, this is more of a shortcut conversion factor.
This is nice and easy. Okay.
So
This looks good so far.
so far so good. Notice we've canceled out the miles. So
Mhm.
we've got our kilometers that we've been hoping for on top. Notice it's on top, as it should be. Let's go ahead and multiply by second conversion factor because I still have to convert my gallons. Now, because gallons are on the bottom, where do you think gallons will have to go in this conversion factor?
I guess it'd have to go on the top just to get rid of it.
Correct.
Seems weird, but I guess whatever's in the top has to go on the bottom to get
Yep.
rid of it.
Excellent, and that's the rule. The rule is always, it has to go on opposite sides. Very nice. So since we've got gallons going to liters, that's our second conversion factor that goes in here. Notice with the liters, we have 3.78. With the gallons, we have 1. And it's going to be a matter of canceling out gallons.
Okay, so I guess you'd multiply the 32 times 1.6 times 1, and then you divide it by 1, and which wouldn't do much, and then you divide it by 3.78.
Excellent.
And if you have two numbers at the bottom, you have to make sure that you hit divided by each time or put them in parentheses.
Exactly right.
All right, so what would you get for an answer?
I got, I'm going to write down what my calculator says, which is 13.54497.
Wow,
That's
that's a lot of numbers.
It's a lot of numbers. Now, the problem with this is that we're
Hi, guys.
not converting. How are you doing there? We're not converting.
We're invading your space.
Excellent. So we have some teachers invading our space here.
Yeah,
So
did you not see that your room was being used?
Yeah, we're
Oh,
recording.
good,
We're
good.
almost done.
we're almost done. We're recording a little lesson. So, no-
Sorry.
so the last thing to do then is to
So
make
there's-
sure we follow significant figure rules,
Yes.
which means how many are the least?
Looks like we have 3 digits in our
So you have 3 here.
no, we have 2 digits that we're starting with.
Starting with 2.
Okay, so I guess we have to end with 2. So we're gonna just keep 13, right?
Well, because of the 0.5, anything higher than 0.5 will round up.
Oh,
So we'll go
yeah.
up to
So it's
14.
gonna make it 14, so.
Excellent.
So 14, what, 14
The units that we want to end up with are
kilometers per liter. Okay,
kilometers per liter. Notice that kilometers never got canceled out, liters never got canceled out, and that's why we've got kilometers per liter for our final answer.
so we had a perfectly American number, and now it's
Perfectly European.
European. Okay, all right, I think I can do it.
Excellent. So we'll get some more of this practice in class.